All right, so looking at number 3 on worksheet 1. Again, we'll do like the XY graph and then transfer that over to the polar graph. I'd probably rewrite that as -2 sine theta plus 2, just because that looks a little bit more familiar, similar to how you did the roller coasters. So the plus 2 means it's up 2, it has an amplitude of 2, and it's flipped. So normally a sine graph looks like that, but we're going to have to flip it and move it up 2. So there's the up 2, that's the easy part. Starts at 0, ends at 0. When I say 0, I really mean the midline, so the new 0. Halfway through we're at 0, and normally we would go like that, because that's what a sine wave does. But because of that negative, we're going to go down first. So there's the sort of the XY graph of that. We've done those graphs before. That was the roller coaster project and a while back. So if you don't remember how to do those at all, then I don't know how you did the roller coaster project, but you need to go back and figure that out. So let's kind of go point by point and put those on the polar graph. So if this is point A, let's see, it's r and theta, 0 angle, and r is 2. So be careful, it's not xy, it's r theta. So I rotate 0 and go out 2. So there's point A. Point B, angle's pi over 2, and the r is 0. So we'll rotate to pi over 2 and go out 0. So we actually just stuck at the origin there. Point C is at pi, and it's up at 2. So we'll rotate around pi and go out 2. Point D is at 3 pi over 2, and it's up at 4. So we'll rotate to 3 pi over 2 all the way down here and go out 4. 1, 2, 3, 4. So there's point D. And I hope to be back where I started with point A, and this will be point E. Let's see, the angle is 2 pi, the height is 2. So if I rotate 2 pi and go out 2, yeah, that point's the same. A and E is the same point. So I didn't connect them as I went this time, but I labeled them so I'd be able to know what order I'm going in here. So A to B, B to C, to D, back to A. And that one, it looks like a limacon, but because it goes back to the origin exactly, we call it a cardioid. Talk more about their names today. All right, 4 or 5? The polar graph of number 5. Okay. So looking at number 5. Well, it's hard to go over the polar graph without first doing this graph, at least for now. So I'll quickly do this graph. Period would be pi, amplitude would be 4. It's a sine graph. So I know what a sine graph looks like, and I need the period to be pi. So there's the first cycle of that sine graph. And then I'll just repeat that again between pi and 2 pi. 0 halfway, maximum halfway between that, minimum halfway there. All right, so point A, I like to just go point by point. It's probably the easiest thing to do for now. So that angle is pi over 4, and we're up at 4. So pi over 4, 4 out to 4. I guess I didn't put it on there. Maybe I should have, but we started at 0. So we went out to pi over. So at pi over 4, we were out at 4. At pi over 2, we're going to be back to 0. I don't want to... How can I label all of those zeros? I'll just label them all 0. How about that? Because that's the origin. So we'll start at the origin, we'll go out to A, and then come back to the origin as we rotate around. Point B, 3 pi over 4, and negative 4. So we rotate to 3 pi over 4, but then back up 4. So point B lands us in the 4th quadrant, which is a little bit weird because you think 3 pi over 4 is in the 2nd quadrant, and that's right, except that the negative radius kicked us back into the 4th quadrant. And again, this little segment, this is where we tried to color code them yesterday, starts at 0 and ends at 0, so it out to B and back. Let's see, C would be at 5 pi over 4, and we're up at 4. So we rotate to 5 pi over 4, and go out 4. Again, this branch started at 0, comes back to 0. Something like that. And then lastly, point D is at 7 pi over 4. The radius is negative 4. So rotate all the way around to 7 pi over 4. We think there's something there, except that we're going negative, so it shoots us back on the other side. And again, it starts at 0 and ends at 0, or at least this little branch does. So that's a 4-petal rose. Again, we'll talk more about that in a little bit, how we could have known that from the get-go. Better? A little bit? So let's see, just real quickly, if you wanted to check, 4 cosine theta would end up looking like that. And if I remember right, it actually repeats itself. So if you try to plot all the pieces, you go around once and then you go around again. So it's like a double circle on top of each other. Number 6, r equals 3. Well, we just go out to 3. I'm going to skip the xy graph. At r equals 3, it doesn't matter what theta is. There's my graph of r equals 3. I guess on this graph it would just be r equals 3 like that. The other one that was assigned was number 3. Let's do a little bit of it. I don't want to do all of it, just because it takes a while. But just to make sure you understand what it's asking, because it's like a table of values, but 3 columns here. First, just take the sine of the angle. So sine of 0 is 0. Sine of pi over 6 is 1/2. Sine of pi over 3 is root 3 over 2. But remember we said that root 3 over 2 was about 0.9. So 0.9. Sine of pi over 2 is 1. We start getting the pattern here. Sine of 2 pi over 3 is root 3 over 2. Sine of 5 pi over 6 is 1/2. Sine of pi is 0. I know most of you are just copying them down, and that's fine, but you need to be able to know these unit circle values that quickly so that it doesn't take you forever to come up with a graph. And even if you have to sketch it real quick, that's fine. Sine of 7 pi over 6 is negative 1/2. Sine of 4 pi over 3 would be negative 0.9. 3 pi over 2 would be negative 1. And then I can kind of just follow the pattern when I see what's going on here. Let's see, so 2 plus, because r is 2 plus 6 sine theta. So that one would be 2. This one would be 2 plus 6 times 1/2, so 2 plus 3 would be 5. This one would be 6 times 9 is 54, so 7.4. 2 plus 6, I can do that one. And then we get some repeating values here. 2 plus 5.4 is 7.4. 2 plus 3 is 5. 2 plus 0 is 2. Now I got negatives. So this will be 2 minus 3 is negative 1. 2 minus 5.4 is negative 3.4. Again, we're doing a lot of little bitty math steps that we assume you can handle. 2 minus 6 is negative 4. And then we start repeating some things. So negative 3.4, negative 1, and 0. If you plot all of those, I'm not going to take the time to plot them all, because after today you'll know kind of the shortcut for what this looks like. This is going to be a limacon with a loop. Again, you don't know how to do that yet. Because it's sine, it's up and down. And I'm just going to pick off my key values here. At pi over 2, I'm up at 8. Mm-hmm. Uh-oh, sure would. I was just circling the 2. Let's back up here. If theta is 0, r is 2. I'm going to skip all the way to the big ones, or the quadrant markers. At pi over 2, we're out at 8. At pi, we're out at 2. At 3 pi over 2, we're at negative 4. So that's a little bit the weird one there. So this goes out, around, but then it does the loop thing. So if you plot all of those values, you'd see that picture. It would just look a lot better than mine because you'd have a lot more points on that. What we're going to do today is talk about how we can know that that's going to be a limacon with a loop that's up and down without plotting, 14 points or whatever how many points that is.